Let's go through an example for the dual algorithm. First, we need to understand that the reported distance is just our neighbor's metric to get there. And so we are looking at the environment on screen with R1 trying to get over to the 10 network. There are 3 different possible ways of getting there from the perspective of router 1. And so we see reported distance. Everything looks good. The ultimate network takes 10 plus another 20, so 30. If we're looking at the pathway through R2, it's 1 plus 10 plus another 10. So that should be 21, right? And we see 21. And then finally, 100, 10, 10, 10. Yep, 130. Sounds right. Then we look at the feasible distance, which is just the metric. It's the overall metric, and now it's just the reported distance plus the metric to get to our neighbors. So we're now inclusive of the last hop, or in fact, the first hop. And so reported distance is what we saw before, and then the metric is everything. And then we call the metric of the successor route feasible distance. Okay. Now with that said, do we have any feasible successors here? How can we test that? Now I'm going to remind you what the condition was. The reported distance of the candidate must be less than the feasible distance. So what we then need to do is we need to figure out something that's less than 31. It has to be less than 31. But what has to be less than 31? This reported distance, right? So let's look at the bottom pathway. Is that going to work? Well, the challenge is 130 is bigger than 31. That's not going to work. So I then compare 30 versus 31. That is, in fact, good enough. And you can have multiple feasible successors, by the way, but in this case, we only have one, just because the topology only lends itself to 1. So the top pathway would be the feasible successor for this topology because it meets that condition. As we can see here, the top pathway would have a status of feasible successor. The route with the best metric, that's the successor. And then you will have the others, those that are not good enough to immediately install in the routing table should we lose the successor, because that's what the feasible successor is. It is vetted for a loop-free path, and the feasible successor will be immediately installed in the topology the moment we lose the primary pathway. So let's say we lose the middle pathway. The middle pathway is completely gone. It goes away. Well, this area becomes unavailable to us, right? And if that becomes unavailable, we're going to have some changes that happen. Those changes are the feasible successor becomes the successor. The feasible successor would become the successor without any network communication. It would happen without any network communication. Now, once that took place, would the non-successor function as a backup pathway? Nope, it wouldn't. Not at least as a feasible successor to the new successor. Why? Because again, its reported distance would be greater than the new feasible distance, because this would become the feasible distance now. 40 would become the new feasible distance. So that's EIGRP operation with respect to dual, and it's really important stuff.